Hello, pre-calculus student. This video is for chapter 5.3 about additional identities in trigonometry. So in 5.2, we introduced the Pythagorean identity, which basically say sine square, maybe I should open it, is it 5.1? No, 5.2. 5.2, we say because of the unit circle, because of the way we define sine and cosine being x and y, and the x and y are in the unit circle. So for any angle, sine squared t plus cosine squared t is equal to 1, right? So that's called the Pythagorean identities. We're going to introduce more. We have 6 trig functions. They're so interrelated to each other. So the first is even and odd identities, meaning if I plug in cosine negative something, would it equal to something else? So let's recall what is even and odd functions. So an even function is a function where f of negative x is equal to f of x. That means whether you put in negative or positive doesn't matter. For example, f of x equal to x squared is an even function because if you plug in 4, you get 16. You plug in negative 4, you still get 16. So f of negative of a number is the same as f of the number. The function is an odd function if f of negative x is just the negative of the original non-negative function. For example, x cubed. If I do f of negative 1, I will do negative 1, which is negative of f of 1. Okay, so that's called odd and even functions. And so for trig functions, if xy corresponds to angle t's sine and cosine, then angle negative t would corresponds to x comma negative y, because this would be the point that shows up if you turn negative t, right? You turn negative t. So look at what is cosine negative t? Well, cosine negative t is still x. The original cosine t is x. So cosine negative t essentially is cosine t. Cosine function is even. What about sine negative t? Sine negative t is this one, right? Is the y, is negative y. So if you negative the original function is negative of the sine t, they're actually equal. So for sine function is odd. So just need to remember this too. If I input negative of something for cosine, I can just say it's cosine t. If I input negative t into a sine, I would move the negative outside, becomes negative sine t. And what else? What else do we have for even functions? Because secant is so correlated with cosine, there's reciprocal. So secant is also an even function. All the other tangent, cosecant, cotangent, they are all odd function, meaning if you plug in a negative angle, it's the same as you do a negative of the original angle. So this is example 7. If secant t is 2, what is secant of negative 2? It's still 2 because secant is even, right? If cotan t is root 3, what is cotan negative t? That is negative of cotan t equal to negative root 3. Right? If sine t is negative 0.05, what is sine of negative t? Because sine is odd function, so it would be sine negative t is sine negatives of sine t. In our case, our sine t is 0.65, so it would be negative of negative 0.65 is equal to 0.65. D. Someone tell me cosine t is negative 0.4. What is cosine negative t? It's still negative 0.4. It's the same as you don't plug in the negative. Okay, so that's signing the odd and even identities. The next one is some other version of the fundamental identities. The fundamental original Pythagorean identity is cosine squared t plus sine squared t is equal to 1. If I divide this particular identity by cosine squared t, in all terms, I will have this become 1, this become tangent, this would be secant. So basically 1 plus tangent square t is equal to secant square t. The alternative form of the identity could be tangent square t would equal to secant square t minus 1 also. And the same for dividing everything by sine. If I divide everything by sine, all of a sudden this become cotangent square t plus 1 is equal to 1 over secant square t. Or you can have an alternative form, cotangent square t is equal to secant square t minus 1, if you minus 1 on both sides. Okay, so that is called the Pythagorean identities. All of these are called fundamental identities or Pythagorean identity. They're useful to convert or rewrite trig function value. So fill in the blank. Secant square t minus 1 was what? Oh, it's equal to tangent square t because we wrote the alternative. 1 minus cotangent square t is what? If I do minus cosine square t minus cosine square t, this will cancel. It's actually sine square t. Okay, so more identities. Quotient identities, by the definition, you can see tangent is sine is what is it called? Y over x, which is just sine over cosine. Cotan is cosine over sine, so we call this quotient identities. Reciprocal identity, which I've mentioned when we were using the calculator, if I want to do secant, I just plug in 1 over cosine. So cosine and secants are reciprocal of each other. Cosecant and sines are reciprocal of each other, and cotangent and tangent are reciprocal of each other. So we have a few simplification. You can see that although they are separate function, but they're so interrelated to each other that we can simplify. For example, sine t times secant t. I would just write sine t. Secant is 1 over cosine t. That means it's equal to sine t over cosine t. Can I write it as one trig function? That is actually tangent t. What about secant t over tangent t? Secant t is 1 over cosine t. Tangent t is sine t over cosine t. Now, they both have cosine t, so I times cosine t top and bottom. We'll cancel it. So that's equal to 1 over sine t. But 1 over sine t is what? It's cosecant t. So you begin with 2 different trig functions to end up being 1. Okay. What about 1 over secant t? 1 over secant t means, what is the reciprocal of secant t? Well, that's actually sine t by definition. What about sine t over tangent t? Sine t is sine t. Tangent t is sine t divided by cosine t, which is sine t times cosine t over sine t, which is multiply the reciprocal. Sine t and tan t cancel, that's equal to cosine t. So you can see you multiply trig functions together. A common practice would be change them to sine over cosine. You can simplify into a more simple one trig function. Okay, so the last one is about someone give you cosine equal to 12 over 13, you don't, and then this angle is in quadrant 4. Somehow we have we read the point of intersection, x is 12 over 13, but we forgot to read y, so find the trig function of all the other value. So we know this is cosine t, and this is sine t. We know if I know cosine t, I can find sine t by what? Cosine squared t plus sine squared t equal to 1. Cosine squared t is 12 over 13 square plus sine squared t is equal to 1. So this is 144 over 144 over 169 plus sine squared t equal to 1. Subtract them. Sine squared t equal to 1 minus 144 over 169. So if I subtract which is 169 over 169 minus 144 over 169. 169 minus 44 is 25 over 169. And then, but all of these are equal to sine squared t. So what is sine t then? I just do the square root, and do I have to do plus or minus? Well, in quadrant 4, sine is negative, so we would do 25, 169, that's negative 5 over 13. If you do the input into square root of 25 and square root of 169 individually. I also have a unit circle for tangent shown up here, because sometimes when we say we want to do unit circle of an angle, say like 3 pi over 4, I know the unit circle is negative root 2 over 2 comma root 2 over 2, right? X and y. And then if I want to do tangent, I do y over x. But that's kind of clumsy. We can divide them like ahead of time and have these values available. So you can refer to tangent unit circle to find tangent value for special angle. Okay, so that's all for this video.